Okay, video 5.2a, Introduction to Integrals Yielding Natural Log Functions. So far we've seen that the derivative of ln x is 1 over x, which would make you think that the integral of 1 over x, the antiderivative of 1 over x dx, will give ln x. Now you have to put the absolute values. They don't for some reason, but we do. This is awful. Okay, now 1 over x, by the way, could be thought of as x to the negative 1. But if you remember when we learned this property when we were first finding integrals, it actually said where n doesn't equal negative 1. Because if you have x to the negative 1, this would become over 0. So x to the negative 1 is really 1 over x, and the integral of 1 over x dx is ln absolute value of x. Now, obviously, if it's 1 over u du, the answer is ln absolute value of u. So what's going to happen is we're going to let u equal the denominator, not the contents of the parentheses in the denominator, but the actual denominator itself. So in this particular case, ignore the red here. The question is the integral of 1 over 4x minus 5 dx. You're going to let u equal the denominator. The derivative, duh, of that is 4 dx. You already have the dx. Introduce the 4, counteract with a quarter. You're now integrating 1 over u du, which is ln absolute value of u with that quarter out in front. Don't forget to change the u back. Okay. It's funny, I don't remember seeing this problem before. Alrighty. So, integral of x dx over 7x squared plus 6, you're going to let u equal the denominator, which is 7x squared plus 6. The du, or duh, of that is 14x dx. They gave us the x dx. We introduced the 14, counteract with 1/14. Now we have 1/14 integral 1 over u du, which is 1/14 ln absolute value of u. Replace the u by 7x squared plus 6, and in this particular case, you don't need the absolute value signs because the quantity inside is always positive, but it wouldn't be incorrect. Okay, over here again, let u equal the denominator, which is your 5 minus x cubed. Your derivative of 5 minus x cubed is negative 3x squared dx. So what's nice is you already have the x squared dx. All you're missing is the negative 3. Introduce it and counteract. You now have negative 1/3 integral 1 over u du, which is negative 1/3 ln absolute value of u plus c, which is negative 1/3 ln absolute value of 5 minus x cubed plus c. All right, here's another one. Let u equal the denominator. U is x cubed minus 3x squared. The derivative of that is 3x squared minus 6x, which at first glance doesn't look really good. But if I factor the 3 out of that, I have 3 times x squared minus 2x dx, which is what I've got up here. Introduce the 3, counteract with 1/3. I'm integrating 1/3 the integral of 1 over u du, which is 1/3 ln absolute value of u plus c, which is 1/3 ln absolute value of x cubed minus 3x squared plus c. Okay, now, not every one of them in here is going to be able to be done like that. Just because you have a denominator doesn't mean that you're going to end up with an ln. For example, here, if you let u equal the entire denominator, the derivative of that has got 1/2, 9 minus x squared to the negative 1/2 times negative, not happening. So this time you're going to go back to the old-fashioned let u equal the contents of the radical, which is 9 minus x squared. Not the entire denominator, just the contents of the radical in the denominator. The derivative of that is negative 2x dx. We've already got the x dx. Introduce the negative 2, counteract with negative 1/2. And I'm going to move the negative 2x dx over here altogether so that I can replace it by du. This, of course, is 1 over square root of u, which is 1 over u to the 1/2, which is u to the negative 1/2. Integrate u to the negative 1/2, you get u to the 1/2 over 1/2, which is times 2 over 1. The 2's cancel, and you're left with negative the square root of u, and of course u is 9 minus x squared. Don't forget we live by the c. Okay, so now we're going to go to improper fractions. Improper fractions are where the degree of the numerator is greater than or equal to. So if they're both degree 3 or both degree 2, that's also an improper fraction. So I'm going to call it a Dolly for Dolly Parton. If you don't know who she is, look up a picture on her on the internet. And you'll see why I call these dollies. All right, so the degree of the numerator is greater than or equal to the denominator. If that's the case, you have to divide the numerator by the denominator to get a proper fraction. It's like if you had an answer of 7/3, you would answer it as 2 1/3. You wouldn't leave a fraction where the top is bigger than the bottom, or equal. So it can be either synthetic division or long division. It's synthetic if the denominator is just a linear binomial with a linear coefficient of 1. So if it's x plus a number or x minus a number. And the interesting part about this, if you don't notice that Dolly's in the house and you just start to integrate, you'll actually think everything's fine. It's not like you'll get to a dead end. You'll just get to the wrong answer. Okay, so here's an example, integral 2x squared plus 7x minus 3 over x minus 2. Notice it's a dolly. Degree of the top is 2, degree of the bottom is only 1. Now I can use synthetic or long division here. I did long division here, synthetic division there. When you're all said and done, either way you do it, your quotient is 2x plus 11 plus your remainder over your divisor, okay? So that's 2x plus 11 plus 19 over the thing we were dividing by. Same thing here. If you do synthetic, that's your remainder. These are the coefficients of your quotients. So that's remainder, constant term, x squared, x cubed, whatever. So again, 2x plus 11. Now it's not like slant asymptotes where we ignore the remainder. You need this remainder. Okay, so now you're going to integrate 2x to get 2x squared over 2. You're going to integrate 11 to get 11x. You're going to pull out the 19. You're now integrating 1 over x minus 2. Let u equal the denominator. The derivative is just dx, so I don't have to introduce or counteract anything. And I'll have x squared plus 11x plus 19 times. If I integrate 1 over u du, I get ln, absolute value of u, and my u is x minus 2 plus c. Okay, here's another dolly. Degree of the top is greater than the degree of the bottom, but we can't use synthetic division here because it's a quadratic. So we have to fill in the missing terms. You have x cubes, x squares, x, and no x's, so we're fine here. But on the bottom, I have x squares and then no x's, so I have to replace that middle term by 0x. You do your long division. I'm not going to sit here and go through that process. And what happens is, after all is said and done, your quotient is x minus 3, your remainder is x. So remember, it's quotient plus remainder over divisor. So our quotient is x minus 3, plus our remainder is x over our divisor, which was x squared plus 3. So integrate x, you get x squared over 2. Integrate negative 3, you get negative 3x. Now here, you're going to let u equal the denominator, which is x squared plus 3. The derivative of that is 2x dx. I've got the x dx. Introduce the 2, counteract with a 1/2. So you have 1/2 integral of what is 1 over u du, because 2x dx is just du. Integrate 1 over u, you get ln absolute value of u, and our u this time was x squared plus 3. And again, I could use parentheses because x squared plus 3 will always be positive. Again, a dolly, degree of the top is 3, degree of the bottom is 1. I can use synthetic division this time. I am missing a term on top though, so I got to fill it in with a 0. So remember that's your remainder, your constant term, your x squared. So it's 1x squared minus 5x plus 19c plus my remainder, negative 115, over my divisor, which is x plus 5. Okay, so we're going to integrate x cubed over 3 minus 5 times x squared over 2 plus 19x. Pull the negative 115 out. You'll let u equal the denominator. The derivative of that is dx. So when you're integrating 1 over u du, you'll get ln absolute value of u, but our u is x plus 5. Here's another dolly. And this is the one people don't notice, which is when the degree of the top is equal to the degree of the bottom. Everybody's obsessed with the degree of the top being greater than the degree of the bottom, but it's also an improper fraction if the degrees are equal. So you will have to do division. I can do synthetic division here. and I will get a remainder of negative 2, and all I get is 1. I don't even get it. Obviously, if you divide x by x, you're just going to get 1 plus. So I get 1 plus negative 2 over x plus 1 because my remainder is negative 2 and my divisor was x plus 1. I integrate 1, I get x. I have minus 2, and then I integrate 1 over u du. You can let u equal x plus 1. Your du will be dx. Now, but then we're also evaluating that from 0 to 1. So if I plug in 1, I get 1 minus 2 ln of 2 minus parentheses. Then I'm going to plug in 0. I'll get 0 minus 2 ln of 0 plus 1. But you got to keep in mind that ln of 1 is 0. E to the 0 equals 1. So this becomes 1 minus 2 ln 2, and of course I distribute. Don't forget these parentheses. And I get plus 2 times 0, which is 1 minus 2 ln 2. Now, they could rewrite that as 1 minus ln of 2 squared. That's using the power property backwards. And of course, 2 squared is 4. So be prepared that it could be written like this in multiple choice.